Hi and Assalamualaikum everyone. My name is Nur Azizah Atira binti Abdul Aziz and my metric number is TE220131. And right now I'm going to present about introductions, importance and theory for this project. First, for introductions, we have filter types and functions. Filters in electronic allow certain frequencies to pass while blocking others. They reduce noise and maintain important parts of the signal. Next is passive and active filters. Filters can be passive or active. Passive filters contain only passive elements like resistors and capacitors. Meanwhile, active filters include active components such as transistors and operational amplifiers. Active filters offer higher performance, amplifications, voltage gain, and cost effectiveness. Lastly, for the introductions, we have filter type and frequency band. There are four main types of active filters, which is number one, low pass, lets low frequencies through and blocks high frequencies. Second is high pass, lets high frequencies through and blocks low frequencies. Third is band pass, let frequencies between a high and low cutoff point through. And lastly, number four is band reject, which is blocks frequencies between a high and low cutoff point. Operational amplifiers in active filters help stage works independently, and the Butterworth filter provides a smooth and flat frequency response. As of importance of active filters, it does contribute a lot in current technology. First, we have the audio and video system. Active filters are crucial in modern audio and video system. They filter out unwanted frequencies and noise to enhance user experience, essential in high-fidelity home entertainment systems and professional audio equipment. Next, we have the automotive electronics, which is active filters reduce electromagnetic interference (EMI) and radio frequency interference (RFI) in automotive systems. It ensures reliable operation in environment like advanced driver assistance system (ADAS) and electric vehicles, which is EVs. Third, biomedical applications. In medical devices such as ECGs and EEGs, active filters provide precise filtering. It captures biological signals accurately while eliminating noise. And lastly, the wireless communications. Active filters manage signal dynamics in wireless communication systems that it ensures receivers handle a wide range of signal intensities, vital for maintaining quality and reliability in congested frequency bands. Next is the theory of bandpass filter. Bandpass filters allow frequencies within a specific range to pass through and attenuate frequencies outside of that range. Okay, for the characteristic, it has center frequency, which is midpoint frequency of the passband, bandwidth, range of frequencies that the filter allows to pass, roll-off rate, rate at which the filter attenuates frequencies outside the passband. For the design, it implemented by cascading two second-order bandpass filters using operational amplifiers. For the cutoff frequency, higher corner frequency FH is the upper limit of the passband and lower corner frequency FL is the lower limit of the passband. And lastly, to avoid interaction between low pass and high pass phases, we need to keep a wide distance between two cutoff points. And briefly, filters in electronics are essential for managing signal frequencies, reducing noise, and ensuring the reliability of various systems from audio equipment to automotive and biomedical applications. And that is all from me. Thank you.
Hi, my name is Logan and I will present about the manual calculation. For our group, we get mid gain 85 and low cutoff frequency 700 and high cutoff frequency 8 kilohertz. And first first step is we need to change gain to dB. 85 is in D 85 is in unitless, so we need to change to dB. So 20 log A, which is 20 log 85, we will get 38.588 dB. Then the second step is find the value of R1, R2 and R3, R4. So all the value of resistance is same, So the cutoff frequency FH equals to 1 over 2 pi RC. So as we need to assume the capacitor since we don't know the capacitor value. So we assume C 2.2 nanofarad for C1, C2, C3 and C4. As you can see from the equation FH equals to 1 over 2 pi RC, we solve and get the R value, which is 9.04 kilo ohm for R1, R2 and R3 and R4. Next step is find RF1 and RF2. From the table, the fourth order n equals to 4. So the equation 1 plus 0.7658 plus x squared close bracket open bracket 1 plus 1.8485 plus s squared. So the 0.765 we take out and equals to will be 3 minus AVO. So we will get 3 minus the AVO. The equation is 1 plus RF over RA. So we need to assume RA equals to 2 kilo ohm. So we will get RF1, which is 2.4 kilo ohm for RF1. Next we need to get for RF2. For RF2 we will get 300 ohm. Next step is to calculate the total gain. AV1 equals to AV3, so 1F RF over RA plus equals to 1F RF of the AV3. Just now we calculate 2.47 kilo ohm over RA, which is 2 kilo ohm. AV1 and AV3 equals to, we will get 2.235. So the AV2 equals to AV4. So 1F RF over RA equals to 1F, since we calculate before, 300 for ohm and 2 kilo ohm. So we will get AV2 equals to AV4 equals to 1.152. So the total gain we get by AV1 times AV2 times AV3 times AV4, we will get the total gain, which is 6.692. And finally, we need to achieve the gain of 85 by adding a non-inverting amplifier to the circuit. So assume RA5 equals to 2 kilo ohm. So 12.822 equals to the 12.822 we will get by 85 divided by 6.6292, we will get 12.822. From that equals to 1 plus RF over 2 kilo ohm. We RF5 will get 23.64 kilo ohm. That's it.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Amir Akul Asra Jamal SD. My metric number is CE 220053. This is for result simulation and testing. This is a skirt for simulation, and this skirt we apply on breadboard and do the testing. There is I got a graph, a good graph from the simulation, and I transfer the skirt into breadboard. This graph from simulation, and I got nearest dB from manual calculation, and FL 7 to 6, and for FH I got 7.88k, nearest to 8k. That from doctor give us the actual result. This is a skirt on breadboard, and I construct from simulation skirt. This is a hardware experiment. I use DC power supply, function generator, and oscilloscope Oscilloscope I use to probe channel 1 and channel 2, channel 1 for input and channel 2 for output. And at oscilloscope I got a nice graph. For V in I use 300 millivolt and frequency 1K, and the output is 28.9 volt. That's a little higher from the dB from manual calculation and simulation. And I got a nice graph, so my skirt function very well. That's all from me. Thank you.